Right, we're asked to multiply and simplify this completely. This means we have to answer with all our negative exponents taken care of and all common factors canceled. So let's deal with this first expression here. This has this 5 on the outside, this exponent. This exponent, by the rules of exponents, gets applied to each of the factors in this expression. And so when we do that, I'm going to raise 5 up there to the 5th power. And then x to the 5th, I'm going to raise to the 5th power. That looks like this here on the side. X to the 5th to the 5th. When I have this is a power to power rule. We multiply these exponents together. So I'd get x to the 25th. In the denominator, I get 3 to the 5th. And then y to the 4th raised to the 5th power is the same thing as we just did over here with the x's. That's going to be the 4 times the 5 is y to the 20th. Alright, and then we're just multiplying here by 3 squared, 5 to the 4th, y to the 6th, and this x to the negative 6. Alright, well, we can do a bunch of different things now. Maybe what I'll do first is I'm just going to multiply this stuff all together just to make it nice. So we multiply straight across. That would give me, let's see, order things around here. 3 squared, 5 to the 5th, x to the 25th, and y to the 6th on top. And on bottom, what I'd have is 3 to the 5th, 5 to the 4th, x to the negative 6, and y to the 20th. Okay, I really done nothing there but just reorder stuff and put it all in one fraction, and it's because I can multiply across. Now what I'm going to do, I have a couple of different things I could do. I could deal with this x to the negative 6. I can move that into the numerator right now if I wanted to. But actually I'm not going to do that. What I'm going to do is I'm going to take care of all of these in one move, and I'm going to apply the quotient rule of exponents to each of these. And what I'm going to do is for each of these common factors, for instance with this 3 here first, I'm going to subtract the exponents from each other. So in this case it'd be a 2 minus a 5, giving me 3 to the negative 3. And then the 5 to the 5th, divided by 5 to the 4th. The 5 minus 4 is 5 to the 1, or just 5. Now the x's, 25 minus negative 6. That always messes folks up. That's 25 minus negative 6. I'm going to write that here on the side. That's the same thing as 25 plus 6. So this would be x to the 31. And then y to the 6th minus 20 is y to the negative 14th. Alright, so that move right there is what we call canceling common factors. And we've consolidated all the factors together. Now the only thing we have to do now is take care of these negative exponents. And to do that, what I'm going to do is move those factors into the denominator. So what I'll get here, I'm going to throw this 3 to the 3rd in the denominator. It's a positive 3 exponent now because I've moved it down below. And this y to the 14th. And then on top I have a 5, and I have this x to the 31. That is a completely simplified expression, and that should suffice. But if I wanted to, I could calculate what this 3 to the 3rd is right here. So I will. 3 to the 3rd is 27. So maybe a cleaner way of writing this would be 5 x to the 31 over 27 y to the 14th.